Alcohols nomenclature. Alcohols can be represented by the general form ROH, where R is a carbon chain, and OH is known as the hydroxyl group that is a characteristic of alcohols. The rule for naming is to take the longest chain alkane, drop the ending E, and replace it by OL. Let's consider this molecule derived from methane, CH4. One of the hydrogens has been replaced by a hydroxyl group. Here is the line diagram. The name, according to IUPAC or IUPAC, is to take the longest chain alkane, in this case it's methane, drop the E, and replace it by OL, which gives us methanol. Let's look at the next examples. Here is the line diagram. There are two carbons, so the base name is ethane. Drop the E, add OL, and we get ethanol. In the next example, we have three carbons. Here they are, just to be clear about the line diagram. The base name is propane, so the alcohol is propanol. Notice we have to add the 1 here to indicate the position of the hydroxyl group. It could also be, as in this case, on carbon 2. Here is a line diagram. This is called 2-propanol. Notice the V shape of those three carbons, which is the isopropyl group, allowing it to be called isopropanol. Both names are correct. Now let's look at some common names you need to know. Methanol is also commonly known as methyl alcohol. Because it can be derived from wood by a method called the destructive distillation of wood, it can sometimes be referred to as wood alcohol, and also another name is methyl hydrate. But the names you need to know are methanol and methyl alcohol. Notice how methyl alcohol is written as two words. Ethanol is similarly called ethyl alcohol. It comes from grain, and so is sometimes known as grain alcohol. Of all the alcohols, this is the only one that is safe to drink in moderate amounts. Methyl alcohol, which can be found in some solvents, is to be avoided. A small amount may cause blindness, and a larger amount can cause death. This alcohol can be absorbed through the skin, so wear gloves if you have to work with it. In the third case, the common name for 1-propanol is simply propyl alcohol. There's no other name. The last example is isopropyl alcohol. Again, two words. If this is mixed with water to form a 70% solution, it's known as rubbing alcohol for use on sore muscles. You can buy this in drugstores or supermarkets. Here are some practice problems. They may look a bit more complicated, but working through them will give you confidence in dealing with ones like these or simpler ones. You should stop the video here, try them, and then come back to see how you did. In the first one, notice we have 7 carbon atoms. We can start numbering from either end, because in either case, the hydroxyl group will be on number 4. So this will be a heptanol with hydroxyl group on number 4, giving us 4-heptanol. For the next one, we must remember that the longest chain must contain the hydroxyl group. So that means number 1 has to start here. Continue to the right. That gives us 6 carbons. If we went to the left, the chain would be only 5 atoms long. This is 1-hexanol. Note that if the numbering started here, the OH group would be on carbon 6, making it a 6-hexanol. We must always give the functional group the lowest number possible, so 1-hexanol is chosen over 6-hexanol. Notice we have 3 carbon atoms here, so that's a propyl group on carbon 2. The name is 2-propyl 1-hexanol. Next one. Again, we start from the top, because that gives the hydroxyl group the lower number, and now the longest chain goes off to the left. With 8 carbons and hydroxyl on carbon 2, we have 2-octanol. This chain of 4 carbons is a butyl group attached to carbon 3, so the final name is 3-butyl-2-octanol. In the next one, we must start counting from the top closest to the hydroxyl group. This gives us 2-hexanol. On carbon 3, we have 2 groups, a methyl group here and a propyl group here. Together, we have the name 3-methyl-3-propyl-2-hexanol. Notice that we have them in alphabetical order. Methyl comes before propyl. If you wrote propyl before methyl, that would be incorrect. Remember from previous lessons that the 2-hexanol can also split up and be written as hexan-2-ol. Although the first name is acceptable, IUPAC has a preference for this method. In the same way, this name can be written as 2-propyl-hexan-1-ol. The bottom one can be written as 3-butyl-octan-2-ol. From the lesson on cycloalkanes, this is cyclopentane. So dropping the E from cyclopentane and adding OL gives us cyclopentanol. The next one is a challenge because it has 2 functional groups, a double bond and a hydroxyl group. Double and triple bonds have the lowest priority, so this has to be named as an alcohol with OL at the end. We number from the end closest to the hydroxyl group. If we ignore the double bond for a moment, the name would be 2-hexanol. If we ignore the hydroxyl group for a moment, the name would be 4-hexene. Now we combine the names like this, 4-hexene-2-ol. The hexene is written only once and the alcohol suffix is written last. Another way is to write hex for 6 carbons, and then add the functional groups in the correct order. The double bond on carbon 4 is 4-ene, and the hydroxyl group on carbon 2 is 2-ol. Hex 4-ene-2-ol. This ends the lesson on naming alcohols.